Okay, so we're still in section 4.5. We're still solving exponential functions. But now I'm looking at the kind of question to where I cannot make them have the same base. So let's look at an example here. So I have 7 raised to the x equals 60. Okay, now the reason I call this no same base is because there is no way that I can rewrite 7 to what power gives me 60. I don't know what that is. It's probably going to be some weird decimal situation. There's no way that I can figure that out. Okay, so instead of being like, oh, no way I can solve this problem, wrong. We can do this. Okay, let me scroll up here so we got lots of room. What we're going to use is the power of the logarithm. So what I'm going to do is I'm going to take the log of both sides. So I have log of 7 to the x equals log of 60. Now, I know you're all thinking, why did we take the log? Why didn't we take log base 7 or log base 60 or log base a million or blah, 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 blah? The reason is that log I can put in my calculator. Okay, so we could also be doing this using the natural log as well. And so I'll try to switch from example to example just so you know that you can use either one and you'll get the same answer. Okay, because I'm eventually going to put this in my calculator to get the answer. Okay. So now, I have log of 7 raised to a power. So I can use my power property and put it in front of my logarithm. So now I have x times log 7 equals log 60. Now, log of 7 is just a number, right? I type it into my calculator and I get 0.0845 blah 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 blah. But you know, Michelle, she doesn't like decimals, so I need to keep it as this what we call exact answer. Okay, but it's just a number. That's how I have to think about it, because if I have x times a number equals a number, I just have to get rid of this, and if they're multiplied together, I just have to divide by the number. So now I get x equals log of 60 divided by log of 7. And so, like I said, this is what we call our exact answer. And when we type it into the calculator, that's when we use our double squiggles. So we get log of 60 divided by log of 7. And so as an approximate answer, it's about 2.104. Okay, like I said, Connect Math will ask for both. It'll want the exact answer and it will want the approximate answer. Okay, so make sure you know how to get both. Do not, in the middle of our equation here, throw in a decimal. You only get the decimal at the very final end. After you've gotten x equals a bunch of mumbo jumbo, logarithm stuff, then you put in your calculator and you get the decimal. No, before that do I ever do something like that. Okay, so let's do some more examples here. All right, so now I have 10 raised to the 5 plus 2x, plus 820 equals 49600. So now I'm going to do the same thing. I'm going to take the log of both sides. But on our last example, we had an exponential equals number. That's always kind of our goal, is we want to get the exponential function all by itself and then equal to a number. So I want to get rid of this piece right here. Okay, so I'm just going to subtract 820. Subtract 820. So I get 10 to the 5 plus 2x equals, let's see, get my calculator, 49600 minus 820, and hopefully we get 48,780. Yep. All right. So now I can again remember either take the log or the natural log, and sometimes one choice is better than the other. For this case, this is my little clue, is that if I have base 10, I'm going to use the log base 10, the one that I can use my calculator, because it will simplify my life a lot. So I'm going to take the log of both sides. So I have log base 10 of 10 to the 5 plus 2x equals log of 48780. Okay, so now if I remember my basic properties from a couple classes ago, this is equal to just my exponent. So I get 5 plus 2x equals the log of 48,780. Now I just have to solve for x. So I'm going to subtract 5, so I get 2x equals. Now, I now have negative 5 plus log of 48,780. Okay, the 48,000 is trapped inside of my logarithm, so I will not get log of 48,775. That is illegal. I will get a big red X on my paper if I do that. Okay, so now I just have to divide by 2, and so I'll divide my whole answer by 2. So I get x equals negative 5 plus log of 48,780 divided by 2. Again, this is my exact answer, and when I put this into my calculator, I should get an approximate. And this is one to practice because a lot of people in my 5A class were getting it wrong, so make sure you practice. So I got negative 0.1557. Sorry, 559. Yep. Okay, so make sure you're doing the correct amount of parentheses and all that good stuff if you put it all in the calculator at once. All right. All right, let's do another one. All right, part C. So now I have 2,000 equals 18,000 times e to the negative 0.4t. Now again, what should my first step be? Well, I want to get the exponential all by itself. So I want to get e to the negative 0.4t by itself. So I need to get rid of the 18,000. Well, if they're multiplied together, what do I do? Oh, just have to divide. So divide by 18,000, divide by 18,000. So I'll get, let's see, 1/9 equals e to the negative 0.4t. Now, in this case, again, I have the choice between log and natural log. In this case, since my base is e, I will use the natural log. So I'll take the ln, take the ln. Now, I have ln of 1/9. Now, since the natural log and e have the same base, I'm just left with my exponent. So I get negative 0.4t. So to solve for t, I just have to divide by negative 0.4. Oops. So t equals the natural log of 1/9 divided by negative 0.4. So that again would be my exact answer. And my approximate answer, when I put it in the calculator, let's see, ln of 1/9 divided by negative 0.4 gives me 5.493. So again, exact, and then my approximate answer here. Okay. Now, so that was the best ones. Now we're going to get a little crazy here, and it's going to get a little more intense. But it's all good. You guys are totally going to be awesome. Okay, so now I'm in a new situation. Now I have 4 to the 2x minus 7 equals 5 to the 3x plus 1. Okay, now I'm in the circumstance where I have x's in two places. I have x's in two exponents, right? I got an x with my 4, I got an x with my 5 over here, okay? Now, we've had that before, but again, I could rewrite them as the same base. In this case, there is no way 4 to any power will give me 5, okay? 4 to any one that I could possibly find pretty easily, okay? Or else it's going to be a weird decimal. Now, so what I'm going to do is I'm going to start out the same way. I'm still going to take the log of both sides. Okay, I'll take the ln just for fun. So I get ln of 4 to the 2x minus 7. Oops, sorry. Sometimes I'm pretty good with writing with this thing, and sometimes I'm not. Equals ln of 5 to the 3x plus 1. Now, I'm still going to apply my power property, so I'm going to bring the entire thing, 2x minus 7 and 3x plus 1, down to the front. Now notice I'm going to put this in parentheses. okay? And the reason I put in parentheses is because I need to remember that I have to distribute my little number over here to both pieces. Okay, now ln of 4 and ln of 5, again, I could type this in my calculator, get some weird little decimal. They just represent numbers. So I'm just going to treat them like a number. Okay, so I'm going to distribute my number to both pieces. Now, when I write this, I write it kind of weird, so just bear with me. Now, I put my x out front, and then I put all my numbers together. And that's because I don't want to be confused about where the x is located. Okay, if I wrote it with my x right here, is that 2 ln of 4x, where I should have parentheses, or what? Okay, that's why I put the x out front, and then all the numbers behind it, because I know that it's x times whatever I have going on behind it. Okay, same thing with my 2. I don't want to put ln of 42 and think, oh, that's really ln of 4 times 2, and be like, oh, ln of 8. Nope, don't want to do that. Okay, so again, I'm real particular about where I put all my numbers so I do not get lost in the problem, be like, what the heck was I doing? And get it all wrong and then be sad. Okay, so I'm going to do the same thing over here. So I have x times 3 ln 5 plus 1 times ln 5 is just ln 5. Okay, again, I know it looks crazy, I know it looks scary, not scary. I do the same thing that I've always done when solving for x. Now I'm going to get everything with the x's on one side, okay, and then everything without an x on the other side. So I'm going to subtract x times 3 ln 5, subtract x 3 ln 5, then I'm going to add 7 ln 4, okay. So let's see what I have. So I have x times 2 ln 4, that was my first piece. Then I subtracted x times 3 ln 5 equals, let's see, ln of 5 plus 7 ln 4. Now, I cannot simplify this anymore. I cannot combine ln of 5 plus 7 ln of 4. There is nothing I can do with that. Okay, this is not like if I have an x plus a 2x and I get 3x, nothing like that. These are separate numbers that I cannot combine to make it look any prettier or any more beautiful. This is as pretty as it gets, okay? Now, over here on the left-hand side, both of these guys have an x, so I'm going to factor out an x. So I get x times 2 ln 4 minus 3 ln 5 equals still ln 5 plus 7 ln 4. Let me get this little guy up here. Okay. Okay, now, to get x by itself, I have x multiplied by something. So I always have to do the opposite deal here. So I have 2 ln 4 minus 3 ln 5, opposite operation, there we go. 2 ln 4 minus 3 ln 5. So my final answer for the exact answer of x is ln of 5 plus 7 ln 4 divided by 2 ln 4 minus 3 ln 5. Woo! That was a lot. That was hard. Okay, but we're going to practice and we're going to be fine at it. Now, when I put this in the calculator, okay, if you decide to put in the calculator all at one time, make sure you put lots of parentheses, okay? So let me see what I get. I get ln 5 plus 7 ln 4 divided by 2 ln 4 minus 3 ln 5. So I get negative 5.5034. So hopefully you guys got the same thing. Okay. Now, I'm going to put another example up here for you to pause the video and see what you get. Okay, try your hardest. Okay, rewatch that other example. Make sure you understand all the steps and work with a partner. Come see me in the Math Hub and I'll get you through it. Okay, so pause the video and see what you get. Alright, so hopefully you got the same thing that I did. Here was my exact answer here. So log of 2 plus 6 log 3. divided by 5 log 3 minus 4 log 2. And then my approximate answer was 2.6778. So if you have any questions over anything we've covered in this video, just shoot me an email or come see me in the Math Hub, all right? If not, move on to the next video.